Chapter 4 Helicopter Flight Controls Introduction. When introducing a student to the flight controls of a helicopter, the instructor must ensure the student understands how each control affects the flight of the aircraft. Figure 4.1. The student may not be comfortable with the helicopter controls for some time, but must understand the function of each control and the reactions of the other controls when control movements are made. For example, if increasing the collective pitch increases power. If the engine is manually controlled, the throttle must be adjusted to maintain revolutions per minute, RPM. If the helicopter power plant has a governor, then the pilot must ensure that power stays within limitations. If the cyclic is moved, then the collective must be moved to maintain altitude because lift has now been redirected into thrust for travel. Anytime the collective is moved, the pedals must be adjusted for heading or trim. Training for this control coordination can be accomplished by using a simulator or a helicopter. Use of a simulator for this instruction reduces student stress levels and may enhance learning. If a simulator is not available and instruction takes place in a helicopter, the instructor should ensure the student understands the location and function of each control. It is also imperative that the instructor stay close to the flight controls during all phases of flight. Flying a helicopter is inherently demanding due to all of the moving parts and the controls available to the student and the instructor alike. It is paramount that the instructor be able to manipulate the controls to keep the aircraft in a safe flight profile at altitude and as the student is moved to flight modes requiring increasingly more vigilance, such as a hover in proximity to the ground, other aircraft, and personnel. As the instructor, develop a safety-focused teaching style while being inconspicuous to the student. This is called the instructor pilot-ready position. It is recommended that the instructor be very close to the controls so the student cannot move the controls too far or the controls will hit the instructor's waiting hand or foot. A good instructor forms a boundary area around the controls in which the student can operate the controls without interference from the instructor's fingers and feet. This boundary formation should ensure the helicopter stays within the instructor's personal limits, yet allow the student to develop a control touch without interference. The instructor should always judge the situation by the flight status and condition of the helicopter, not by what the student is doing. It is what the helicopter is doing that is important. Whether using a simulator or helicopter, beginning the flight instruction at altitude is a good way to allow the student to manipulate all of the controls at one time and with a larger margin of error than beginning the flight instruction at a hover. As the student's proficiency increases and the flight control inputs become smaller, the student can then be allowed to fly lower and slower, ultimately terminating an approach to a hover. A less preferred but widely used technique is to let the student operate one control at a time while the instructor operates the others so the student can get the feel of a control and its function in flight. Always emphasize making smooth, coordinated control inputs. Collective pitch control. Explain to the student that the collective changes the pitch of the main rotor blades, angle of incidence, and, as a result of that pitch angle change, is used to increase or decrease the blade angle of attack, AOA. This is accomplished through a series of mechanical linkages that changes the angle of incidence of all blades simultaneously, or collectively. Figure 4.2, demonstrate on a static helicopter how pulling up on the collective increases the pitch of the rotor blades while lowering the collective decreases the pitch. Explain how the collective is used to increase both lift and thrust by changing the lift vector. Stress to the student that the collective must be kept free of obstructions at all times. The instructor must ensure the student understands the importance of ensuring the collective is free to move through its full range of travel and is kept clear of anything that could limit movement, such as a thigh, map, cell phone, camera, or even an article of clothing. An instructor may demonstrate how to use the collective to initiate takeoff, climb, and descent. One technique for practicing the application of collective pitch occurs during flight. Climb to a safe altitude and allow the student to operate the collective to climb, descend, and maintain altitude during a turn. Explain the proper application and use of collective friction. Demonstrate how the collective is used to maintain a constant altitude during accelerations and decelerations. During this demonstration, the instructor initially maintains level flight with the other controls and gradually allows the student to have the others' controls as proficiency is gained. Throttle control. A student must thoroughly understand the intricacies of the helicopter being flown. While some helicopters have a governor to control the engine revolutions per minute, RPM, or a correlator to increase/decrease throttle inputs automatically to an acceptable range that generally requires some pilot input, other models rely solely on the pilot's manual input of twisting the throttle. Figure 4.3, even when RPM is controlled by a governor or fuel control system, emergency procedures require manual operation of the throttle to control engine and, ultimately, rotor RPM. Manual operation of a non-governed throttle can be explained and demonstrated during instruction on the collective. A simple explanation that students may be able to relate to is comparing the manually controlled engine to a manual car transmission and a governed engine to an automatic transmission. Proper use of the throttle is an integral part of maintaining both engine and rotor RPM during flight. Explain the use of throttle friction in reducing the sensitivity of the throttle. While students who have experience riding motorcycles or other powered recreational type vehicles are familiar with the concept of a twist grip throttle, instructors must guard against twisting the throttle in the wrong direction for a given application. Training on governor override or manual throttle operation should be explained, but a demonstration and practice should occur only after the student has mastered all the control inputs required to fly. Explain that revision to the manual mode of operation is an abnormal, or emergency, procedure and is almost exclusive to reciprocating powered helicopters. Few large turbine-powered helicopters have a manual override function suitable for training. Stress to the student the importance of checking the throttle during the pre-flight. The throttle, whether governed or not, must have freedom of movement from stop to stop. There should be no binding or excessive stiffness in the operation of the throttle. Point out that throttle control friction must be decreased before checking the throttle. Special attention should be given to ensure that the throttle/power lever is set in the start position prior to starting. This position varies between aircraft design and is explained in the rotorcraft flight manual for the particular helicopter being flown. Improper throttle or power lever settings can lead to overspeed of a reciprocating engine due to the clutch, or engine temperature exceeding limits with turbine-powered helicopters. Cyclic pitch control. A student should understand that moving the cyclic control tilts the rotor system in the direction the cyclic is displaced, whether it is fore or aft, or in a side-to-side motion, thereby providing thrust in the direction the rotor is tilted. Figure 4.4, this cyclic movement from the pilot's right hand results in the aircraft moving in the direction the pilot desires as the cyclic is displaced. Any movement from the cyclic has a corresponding effect on the pitch of each blade, either increased or decreased pitch as they move or cycle through every rotation 360 degrees. This enables the aircraft to move in the direction the pilot desires. Emphasis must be placed on keeping the cyclic free of obstructions. Students must understand the importance of ensuring the cyclic is free to move its full travel and to keep it clear of anything that could interfere with or limit its movement, such as knee boards or passenger legs. Demonstrate the cyclic input required to hover. Initiate a takeoff and climb to a safe altitude. Demonstrate how the cyclic is used to maintain the pitch and bank attitude of the helicopter and maintain a constant airspeed during climbs, descents, and turns. Explain the use of the cyclic trim system to relieve cyclic pressures and reduce pilot fatigue. During the pre-flight inspection, demonstrate movement of the cyclic in all quadrants, and allow the student to observe the inputs made to the swash plate and main rotor system. Anti-torque control. Discuss the primary purpose of the anti-torque system, to counteract the torque effect created by the rotation of the main rotor system. The anti-torque system could consist of vectored thrust from the engine or be provided by a tail rotor. Explain that in either case, the function is the same. Most training helicopters will utilize a tail rotor for this purpose. Figure 4.5, anti-torque pedals change the pitch of the tail rotor and provide the thrust required to counteract the torque effect. Discuss how the pedals are used to maintain coordinated flight during cruise flight, but are used for heading control during hovering flight. Operation of the anti-torque pedals through the full range of travel allows the student to observe the pitch change in the tail rotor. Always remind the student of the safety hazards of pinching, moving parts, and to keep well clear while the controls are being moved. Explain to the student the importance of keeping the anti-torque pedals free of obstructions and having full range of movement. Emphasize that loose objects that fall during flight and are not retrieved could jam the pedals and reduce aircraft controllability. Demonstrate pedal inputs during a hover. Figure 4.6, climb to a safe altitude and allow the student to operate the pedals to maintain coordinated cruise flight. Demonstrate how the pedals are used during climbs, descents, and coordinated turns in cruise flight. Explain that when increasing collective pitch, anti-torque requirements are greater, when reducing collective pitch, anti-torque requirements are less. During this demonstration, the instructor maintains coordinated flight with the other controls. Practice. Once the student has practiced with each of the controls individually, while still at a safe altitude, gradually turn over control of the aircraft one control at a time. Remember, stay close to the flight controls. When the student has a basic understanding and demonstrates the ability to control the aircraft at altitude in cruise flight, use the same procedures to introduce aircraft control during hovering flight. Allowing the beginning student to fly down a runway or taxiway, or other set ground track. Making slower and lower approaches will almost naturally lead the student into the hovering mode, allowing a better understanding of control response while avoiding the overly early and frightening attempts at hovering flight. This technique allows them to learn the changes in the helicopter's response to lower airspeeds and ground effects at their own pace. Instructor tips: always practice positive exchange of controls, procedures, and acknowledgements by using a three-way positive transfer of controls. Figure 4.7. This is particularly important in the early stages of training when either the student or the flight instructor is on the controls for a long period of time. If the instructor or the student is following along on the controls, ensure that both understand who has ultimate control over the flight controls. Always emphasize making smooth, coordinated control inputs. Always stay close to the controls. Be ready to take control of the aircraft and never underestimate the student's ability to make a mistake. Always practice initial hovering over smooth surfaces, free of any protrusions that might catch the landing gear. A lack of protrusion may allow the landing gear to slide freely in case of accidental ground contact. Chapter summary: this chapter provided the instructor with techniques of introducing flight controls and their application to a student. It also offered the instructor safety-related points of emphasis regarding helicopter flight controls.